Hello everyone. Myself Sagar Somaya Hiremath, working as assistant professor in Walchand Institute of Technology, Solapur. Today we are going to see Infix to Postfix conversion with the help of an example and a program. So at the end of this session, student will be able to apply the stack based algorithm to convert a simple infix expression into postfix form. And student also will be able to design new practical problems involving mixed operators and parentheses. These are the today's content: expression types, operator precedence and associativity. We have to see the algorithm to convert infix to postfix conversion using stack. Another example, how stack is implemented with the help of infix to postfix example, and we have to see program. First, basically, you need to know expression. What is expression? An expression is a collection of operators and operands that represent a specific value. Operator is nothing but a symbol which perform a particular task, and operands are the values which operator can perform. For example, A and B are the operands and plus is the operator. For example, A plus B is your expression, then A and B are the operands and plus is your operator. There are three type of expressions. First is infix expression, and second is postfix expression, and third one is prefix expression. In infix expression, operator is used in between the operands. For example, A plus B. Here A and B are the operands and plus is the operator. And in postfix expression, operator is used after the operands. AB plus. Here A and B are the operands and plus is the operator. And in prefix expression, operator is used before the operands. Proceed further. After evaluation, while evaluating the postfix expression, infix to postfix conversion, we have to check the operator precedence. Precedence is nothing but the evaluation order of the particular expression. Which operator is evaluated first, that we have to check with the help of precedence. And if the same precedence is there, we can check and solve that particular problem with the help of associativity. Either the left evaluation, left associative, or right evaluation, right associative. These are the operator precedence. The highest priority is for the brackets, and second highest priority is for exponent, and third highest priority is for into, divide and modulus symbol, and lowest priority is for plus and minus, and all the operands have the lowest priority. Okay, and these are the associative rules. For example, for exponent operator, right to left evaluation is there, and remaining of the operator, left to right evaluation is there. Operator precedence is nothing but it's a rule that decides which operation to do first in an expression. If two operators have different precedence, the one with higher precedence execute first. Example, A plus B plus C. In this case, all the operator have the equal precedence because plus and plus have the same precedence. So this expression is evaluated from the left to right. Example, A plus B plus C. First, you have to check A plus B, must first evaluated A plus B expression, and then you have to add C expression. And in another case, A raised to B raised to C, both the operator have the same precedence. So you have to evaluate, because raised to has a right associative rule. So you have to evaluate first B raised to C, and then A raised to this B raised to C result. You have to raise to that particular result to A raised to. Means in this example we clear that for the left associative you must execute from the left to right, and right associative you have to execute the expression from the right to left. This is an example. Before starting example, we have to first check the algorithm. Step by step we have to learn from the basic how infix to postfix conversion will be executed using stack. First step is start. For each expression you have to scan from the first character to the last character, from the left to right you have to evaluate first. For each scanned operator, you have to, if the left parenthesis is there, you have to push into the stack. If the operands are there, for example, operands is nothing but the capital A to Z, small a to Z, or 0 to 9. These are the operands. Add it directly to the postfix expression. In this case, your expression is an array, and also postfix expression is another type of array. We are storing the result of postfix expression into another array, that is your output postfix expression. If the right parenthesis is there, while evaluating the expression from left to right, if you got the right parenthesis, then you have to pop the operators of the stack until you get the lowest precedent at the top. If it is at operator example plus minus into and divide and raise to, then you have to check the left associative rule. For example, if the operator is left associative, then you have to check the precedence of top of the stack, means which operator is at the top of the stack is priority is greater than or equal to your scanned operator. For example, stack contain the into symbol, and you have to push the current operator is your plus operator, means stack contain the into, that is highest priority as compared to plus, into is greater than plus. Then you have to pop the operator from the stack and add it to the postfix expression. This is a left associative, for left associative. And for right associative, you have to check the precedence of top of the stack is greater than precedence of the scanned operator. The only difference is between left associative and right associative operator is that in left associative you have to same precedence also you can pop, and stack contain the greater precedence as compared to the scanned operator, then also you can pop. But in right associative, top of the stack contains the greater precedence as compared to the scanned operator, then you have to pop the operator. And last step, push the scanned operator onto the stack. Okay. In this algorithm, we clear that you have to remember there's only two rules. First rule is check the precedence of the operator. If the precedence is higher than the scanned operator, if the stack contains the precedence of the top of the stack is greater than the precedence of the scanned operator, you have to pop the element from the stack. Otherwise, you have to push the scanned operator into the stack. You have to remember the right associative rule. For example, greater than raised to is a right associative rule. You have to check the same precedence. In left associative, you have to pop the elements, and in right associative, simply you can push the element onto the stack. This is an example. In this example, A plus B into C plus D. First character is A. So, it is operand. So, you have to directly put into the postfix string. Next operator is plus. If operator is there, you can push into the stack. Plus is an operator, you push into the stack. Again, next symbol is B. Next character is B. Because it is an operand, you directly put into the postfix. And postfix is now A and B. And next operation is your into. Because stack contains the plus operator and into has the highest precedence, you have to remember that stack always contains the highest precedence operator at the top. Means plus is your current previous stacking element, you can directly push into on the top of the stack, because into has a highest precedence as compared to the plus. Next operand is C. Because it is an operand, you directly put that operand into the postfix string, and postfix string is now contain A, B, C. Next is at your plus symbol. Now check the precedence of plus is lower as compared to the into. You have two elements in the stack, one is plus and another is into. So first you have to pop the into and add to the postfix string, because highest priority element is at top of the stack is into, but plus is at lower priority index. We are not able to push lower priority character operand onto the top of the stack. So you have to pop into and add to the postfix string. You have to pop into and add to the postfix string. And another one is plus has a same priority and plus is a left associative. This rule is very much important. Listen carefully. Stack contain the plus and your next expression operand is plus. So both have the same priority, but plus is a left associative. So you have to pop the plus also. If the case is that, I am taking another example, your stack contain raised to symbol and your expression also has a raised to symbol, it has equal precedence, but raised to has a right associative. At that case, you can directly push raised to on the top of the stack. Means already stack contain the raised to, again you have to push raised to onto the top of the stack. Is this clear? Okay. So you have to remember this example carefully, and you have to check some other examples. In that example, left associative rule for equal precedence and right associative rule for equal precedence. And last, you have to check the character is D. Directly you have to write in postfix form. And last step is you have to pop all the elements of the stack, that is you have to pop plus also. This is your final expression, ABC into plus D plus. Okay. In this example, we clear that how infix expression is converted into postfix form with the help of real stack structure. I will repeat rule again. If operand is there, you have to directly post in postfix expression string. If operator is there, you have to check the precedence of the operator. And remember the rule, stack contain the highest precedence as compared to your infix current input, then you have to pop the element. Otherwise, you have to push the element into the stack directly. And for equal precedence, you have to check whether the left associative is there or right associative is there. If left associative is there, you can pop the element. For example, stack contain the plus and your expression also contain the plus, then you have to pop plus. And if right associative is there, for example, stack contain the raised to and you have to check with the raised to, that is same priority, but raised to is a highest same precedence and right associative. For that, you have to push raised to on the top of another raised to, means stack contain the two raised to symbols. This example and this important point should be noted. And another point is, now you have to check another example. A raised to B raised to C plus D. First you have to check the symbol A, directly put into the output, raised to symbol push into the stack. B is symbol, you have to directly put into output. Again raised to symbol, you have to push into the stack, because raised to has a and stack raised to has the same priority, but due to right associative rule you directly add raised to on the top of another raised to. Like this example will continue. You have to check the bracket, push into the stack, again C symbol directly add to the output, plus symbol add to the stack, D symbol, D character add to the postfix directly output, and if round bracket close is there, you have to pop all the element till the bracket open. A, B, C, D plus, and last step is your pop all the remaining stack elements and add to the output A, B, C, D plus raised to. This is your final answer. Now last part is a program. So in this program we have to convert the infix to postfix expression. For this stack array we have taken of character, size is at maximum 100, initial value of top is equal to -1. We have to write the push function, pop function, pick function, and you have to convert infix to postfix form. What is the logic of push? Basically you have to push the character C, that we call push function called from the void main. If top is less than max -1, increment top by 1 and add the character at the top of the stack. For example, initial value of top is -1, you have to increment top by 1, means -1 plus 1, top index at 0, you have to insert the stack of 0 is equal to first character. Like this, again increment top by 1, top will increment by 1, top index previous index is 1, 1 plus 1 2, stack of 2 will go another result. Like this push operation will be performed, and in pop operation you have to check the empty condition by checking top not equal to -1. ch is equal to stack of top, you store character from the top of the stack. For example, stack contain the 4 element, your index starts from index number 0 because it is array 0 1 2 3. Remove the third character, store in ch, decrement top by 1. Again from third character you have to check, again pop is there for second character and third first character. Like this stack pop operation will be performed. And what is a pick? Pick will return the current top element of the stack. These are the three basic operations, push, pop and pick, that are already covered in the stack. Now you have to check the precedence. For that we have used the precedence function. If passed character OP is raised to symbol, you have to return that its priority 3. Again for into and divide have a equal priority, we have to return the 2. For plus and minus you have the equal priority, return 1, else return 0. Now you have to check the void main function. Infix is your first infix string, we accept the infix string from the user, and you have to store the result into the postfix string. First initial value of I and j initialized to 0, enter infix expression, gets function is to take the input infix, and while you have to read the character by character till \0. \0 is a termination for the string string. Last character is at \0. Read the input first character and store it in ch. Ch is equal to infix of I. If that character is alphabet or number, this if function gives the result 1. Means is alphabet number, if this condition is, if function is executed successfully, if the character contains the alphabet or number, it will return 1. Inside if 1 is there, means condition is true. you have to store that particular alphabet or number into the postfix of j. We have to use the different index. I is for infix of I and j is for postfix of I. Postfix of j is equal to ch. Again j is equal to j plus 1. You have to increment the value of j to 1. In second case, if alphabet is there, you can directly add to the output string. This is the first case. In second case, if the scanned character is opening bracket, then you have to push that opening bracket into the stack. And else if scanned character is closing bracket, then you have to pop all the elements and add to the output string, because what is the rule? Inside, if you find opening bracket, you have to push into stack, and all the operators from the opening bracket to closing bracket you have to push into the stack directly. If you found closing bracket, then you have to pop all the elements, pop all the operands from the operator from the stack. Postfix of j is equal to pop j is equal to j plus 1. Like this while loop will continue, and last you have to remove the opening bracket from the stack. If your expression contain alphabet or number, it will go if block. If your expression contain opening bracket, it will go else if second condition. If your expression contain closing bracket, it will pop all the elements and remove the last opening bracket. Otherwise else you have to check the precedence of the stack. If the precedence of peak element means top element precedence should be greater than or equal to precedence of your current character, you have to pop that all the elements and increment j is equal to j plus 1. And last is your push the current character onto the top of the stack, increment I by 1, and if there are any remaining operators into the stack, then you have to pop all the elements. You have pop all the elements and initialize last character to \0. It is the termination of your postfix string. In this way, we conclude that evaluation of infix to postfix expression. These are the some references. You can refer this example, and thank you for the listening this video. Thank you.